Hi, my name is Paul Henschel. Thanks for having me. I'm a developer from Germany. And this is my Twitter account. You can check it out. This is not an O, it's a 0. And today I'm going to show you how to make games in React. I guess many of you, they will wonder, why the hell would I make a game in React? The thing is, it just gives you a new tool for expressing yourself. So could be a game, could be front end, could be anything really. So maybe you have a story to share, political messages, whatever. So this just helps you to open new doors, to do things that previously wouldn't have been possible. The thing that we are going to use is called React 3 Fiber. This is a library I once made. It's a reconciler or a wrapper, whatever you want to call it, for 3JS. And you can see here some fancy demos going on. The thing where it originated from is called Buerli, Buerli.io. You can check out here. This is what we are doing at work, and this is where it comes from. It's basically like a open, embeddable CAD platform for the web. And we just needed something to make it more React-y, to control the scene in a better way. And this is very specific. You can make models with it, variant configurators, visually or headless. But what I'm going to do, to show you today is has to do more with the library itself, React 3 Fiber, and how you can use it, and everything from a beginner's perspective, because that's what I am. I have never made really games before, but if you can make something like this, you, I guess, can do everything, or at least you have the starting grounds. First, I would ask you to go to this repository and check out the fundamentals section. In here, you find your starting ground, documentation and stuff like this, just to get in, to get an idea how it's all coming together. Today, I won't get too much in depth, but we are just learning by doing. And obviously, you also need 3JS by side the documentation, because the things that I'm going to do today, I'm not going to explain how 3JS handles it and so on. So let's get right into it. The thing that we are doing today is, I think it's called Arcanoid. It's like a small game that we're going to do. The pedal, I think, cannot be seen because of the video screens, but either way, we will make a very reduced version of this today. And yeah, let's get going. The first thing is I'm going to explain to you how the 3D space works. You have 3 axes. The X1, it's a horizontal one, Y is vertical, and then you have depth. So this is how the 3D space works. 3D is 3-dimensional. Then you have a camera. It's like looking onto the area that is visible, and it creates something that's called either a frustum or a viewport. It's a visible area of our screen. And in this thing, we are going to project a couple of primitives, objects. One will be the pedal. We will tie this to our mouse to make it interactive. And the other will be this little ping pong ball. We make it gravitate downwards. So we are also working with physics. So let's jump right in. The first thing, and this may be the most important one, that you fetch from React 3 Fiber is called Canvas. Basically, it's a representation of the WebGL context. Everything that goes in here is visible. In 3JS, you have a couple of things you can do, but the most important one is called a mesh. And if I save this, nothing will happen. You see nothing, because a mesh is a representation of a shape, and it also has to describe how the shape is looking. So the shape could be, for instance, a sphere. Now we have a sphere. If I save this, we see it. But it appears white because we need to give it a material as well. There's many materials, but the one that I'm always using, and I suggest you will use this too, at least as a beginner, is called Mesh Standard Material. And this one can receive a color. Color. Let's say hot pink. If I save this, it's going black, and this is because it doesn't receive any light. And if you've ever been into photography, it's the same principle, really. Things are affected by light inside the scene. And if you know what, for instance, is fill light, strip light, or main light, you are good. If you don't know what this is, don't break your head. You can just wing it. You can just try stuff out. So at first we are the ambient light. That means light comes from everywhere. And this sphere looks pretty dodgy. It's flat. And this is the same as in photography. If light comes from every angle, there's no shadow. So we need a main light, a light source that is a little bit angled. And let's put a point light into the scene, like this. We position it, let's say upper right. And now you can see a little bit of shading going on. Let's make the ambient light less intense, like that. And now you can see it in a better way. Also, there's a trick that I always use. It's called a strip light. Again, it's this is like basic photography. So now it's the light that comes from behind, and it creates this little edge. This sphere looks pretty rough. In 3JS, if you make a sphere or any object, you have something called arcs or constructor arguments. The first one is the radius, and the other one is segments, like how smooth this thing is going to appear, as you can see. So this is these are the basics. Now you know how to put stuff into the scene. Now you know how to put up lights. And you might be wondering, this looks pretty strange because these aren't divs and spans. These are meshes and point lights and so on. So don't think of React as something that is only for the DOM, for the web. React is a cross-platform component standard. It can handle everything. So here we are putting 3JS elements into the scene. Because this is React, we can now rip it out and create components, reusable components. So we have created a ball. This will be our ping pong ball. Let's put it up here and back into the scene. And there we go, nothing should change. But now we have made it reusable. The first thing that we can do is using properties like this. Now I could, if I wanted, I could go in here and give it a different size, different radius, whatever. I guess we're good. The ping pong ball should be white, and maybe it shouldn't be so big, like this. That looks good. Now we need to have our pedal. Let's also call this pedal. I have copied the component. This one takes different arguments. We want to have a rectangle or a box like this. It also shouldn't be a sphere, it should be box buffer geometry. So if I save this, oops, I need to put it into the scene. Pedal. And yeah, that looks good. Let's put this down here. Now I have the pedal, but I don't want a box. I want something like a stretch rectangular. So more like this. Let's give it another color. Let's say light blue. Okay, we are good. We have two components, the ping pong ball and the pedal. And now we need to make them interactive and react to physics, basically. So this is the next thing that we need to do. Physics are very, very complex, and there are many libraries that you can choose, Mo.js, Canon.js, and so on. For now, we will use Canon.js, and that's a library that we made. It's on the React Spring GitHub organization. It's called Use Canon. And it could be the easiest way you've ever seen to make physics possible. And I will show you this. Let's add it. Physics, it's a provider like this. Now we have physics. And can I make this? This thing really sucks. Okay, I put it here. I save this, nothing happens, because I need to tell the physics world about these objects that I have put into the scene. And the easiest way to do this, this library gives us a couple of hooks, and they think of them as an approximation. We have created a sphere. This is the little white thing you can see here. And we need to tell the physics world that this is a sphere. And we get a couple of hooks that describe how geometry looks. And they work in the same way. We have the hook here. The hook wants to have arcs, the same ones. So in this case, it wants to know the radius. And to behave in a physical way, an object needs to have mass. So we say mass 1. And all that we need to do is we need to tie it to our object. We get a reference. We put this to the mesh, ref. I can save it. And as you can see, it's dropping down. So physics is working. The thing is that it is way too slow. So we should give it a little bit more gravity. There's a property on here that says gravity. And it has 3 axes. Remember, you have 3 axes in space. And we want gravity to come down, like from the y-axis. Upwards is positive values, downwards is negative values. So let's give it, for instance, minus 30. And that should look better. Yeah, that looks way better. The next thing is the pedal. Nothing happens in here because only the ball is recognized in the physics world. There's another hook for this. The same principle is an approximation. So it's called usebox. This time we don't give it mass because we want to control it with our mouse. That's the basic principle behind this. But it also just takes the same arguments that the box took. So if I do this and same thing, I need to tie it to our mesh like this, and nothing happens because these two occupy the same space. So there's something else, it's called API. And with this API, you can put, enact on it, put a force on it, put it in a certain spot, and so on. Normally, you would position objects in here, as I've shown you with the light. You can make a position, and then it should be left and right like this. But in our case, it's not like this because the physics world it controls this mesh. So we need to find a different way. And there's a hook called useFrame in React 3 Fiber. And this is the most important one of them all. This one basically runs 60 times per second. It subscribes this component to the frame loop. That's what it does. So be careful. Everything that you put in here should not be expensive, but you can animate the object in there. And what we're going to do is we take the API. It has also a position. It has sets where we can put in the 3 axes. And useFrame gives us a state model. The state model contains many useful things like how big is the viewport, responsiveness, but it also has mouse data. So we can go in here, state, mouse X, and if I save this, I should be able to move this thing left and right. The thing is, this doesn't do much because these are normalized mouse coordinates, 0 in the center. If I go to the right, it's 1. If I go to the left, it's -1. So all I need to do is I need to know how big, how big is the width of my viewport. So I say state viewport width divided by 2, and that's it. Now it follows along with the mouse. And all that's needed to do, I need to put it down. So that's minus state viewport and height divided by 2. And now it's here. And as you can see, it's already working. It catches the little sphere. And if I move down, it goes away. But we wanted to bounce back. So there's something in physics. I have slept in physics school, in the classes, I mean. But the property is called restitution. Restitution is how strong is the bounce back. Right now, it has no restitution at all. So there's something called default contact material. in here I can describe how the material work in the physical world. So I say restitution, give it a little bit like higher than 1. And now you can see the ball is actually bouncing. And not just this, the bounce is increasing, it's increased. The next thing that we notice is the ball drops down and the game is basically dead. So we need something to reset, to respawn the ball. And for this, there's many ways you could do it, but the easiest would be a contact plane. We put a physical object, doesn't need a visual representation, and it's supposed to catch the ball. So we say use plane, give it an object again. This one also does not have mass, it stays fixed, and we need to rotate it. The reason for this is because if you put a mesh or a plane into the scene, it will appear, like this, and we need to rotate it so that it becomes a bottom or a surface. So we say rotation. This is going to be math pi. It's 1 rotation by 2, so we rotate it by half. And this should be it. And also now we need to put it a little bit down. It should be at the bottom. This is on the y-axis. And now we need to know the viewport. How big is the viewport? There's another very important hook. It's called use frame. This one gives us the viewport. Use 3. In here, this is responsive. So every time the user resizes the screen, this component will be re-rendered. So let's just put this in here. Viewport height, and it should be below. And if everything is working, then it should be fine already. So let's see. Yeah, okay, so we see we have this physical plane that's down there, but the problem is it's bouncing the ball back up, but we don't want this. We want to respawn the ball, so that's also easy. These hooks, they have something called onCollide. So every time they are hit, we are called back. And all we need to do, we get the API of this ball, and we just reset it. Position, set, we set it to 0. So let's try this out. It works, but it maintains its velocity. So we also need to reset the velocity. It's the same thing, velocity. And there's this. Now it respawns. We could actually make it, give it a little upward velocity. Then you can see it's bouncing up a little bit. And these are the bare bones of our game. The thing is, it doesn't do very much because the thing can just bounce up and down. So let's angle the pedal a little bit. We do this in the pedal component. We already have 1 line of code for position so that it follows the mouse. Now we add another for rotation, like this, set. And again, the camera comes from the from the Z axis. So we need to rotate it around this axis. It's this one. And we just say state, mouse X. This time we multiply it with an angle because rotation takes angle. And we take a fraction of this, like let's say 5. So, and now happens this. This is already like close to a game. You can see you have to interact with it. You need to watch out. So there's a couple of things we could do now. I don't want to stretch it. This should be a very reduced example, nothing more. We could put invisible walls at the side so that this could bounce back. But let's not do this. Let's just add a couple of enemies, and then I guess we are through. So I make a function called enemy, and I copy everything inside the pedal like this. But this time I also give it props. Let's take a color and the rest of the props. And let's spread the props over here. So, and wire up the color here. So now the developer can put enemies up. I create one, I say color, orange, and let's give it a position like this. 0, 0, 0. So where do we want to place it? Let's move it upwards a little bit. And on the left side, arcs is not defined. Okay. One. These are width, length, height, as I explained before. This one forgot to copy this one. Okay, now it should work. Okay, there's our enemy. And as you can see, it's also responding. I can ping it, and I can put many of them inside the scene. Let's make another, let's make this one hot pink. Put it on the other side and put it a little bit higher. And there we go. Maybe still higher, maybe like this. So these are the bare bones of our application. I won't go further than this because we are stretching time. What I wanted to show you with this is that all this stuff is not hard. As you can see, we only use like 60 lines. And you don't need much math. You can wing it, you can try stuff out. And the most important is that you have fun. So if it interests you, you can find the real example, the more complex one on my GitHub page. I will put up the reduced version as well. And yes, if you make something cool, could be game, could be anything, just make sure to ping me on Twitter. I would love to see your creations and hope you had fun learning a little bit about WebGL, graphics, 3JS, React Fiber in React. And yes, that's basically it. Thanks again for having me. Have fun and goodbye.
Hey, Paul.
Hi.
Thank you for joining us and this amazing demo. I have to say, I used to work at an advertising company doing development for ads, and once was in a team that built a 3D game with 3DS, if I remember correctly. It's been 6-7 years, so forgive me if I'm wrong. And that looked nowhere as easy. I was not involved in the 3D part. That looked nowhere as easy as you make it look. You make it look, like 60 lines, and you built this bouncing ball pedal Space Invader start. Arkanoid. It's crazy. So there must be a lot of development that went, of course, into the engine, React Fiber, that we can't go into detail now, but it looks really powerful. So thanks for giving that to the community. I want to go to the first question from the audience. The question is from Cynthia. Any recommendations for basic photography skills for those who want to use React Fiber but don't have a photography background?
Okay. I guess just wing it. Just try out. You can put lights into the scene, see how it looks. But you will find it in Google. Just Google for photography basics, so that you have a basic idea what is a fill light, what is a strip light, what is a main light. These are essentials for photography, and this stuff will really help you.
Yeah, just to get a hang of the terminology. And from my experience, there's always photo people are really happy with what they're doing. So if you have someone in your environment that does photography, they will be happy to help you.
Yes.
Just like developers, no disrespect to developers, of course. Next question is from Danilo. With WebAssembly becoming more prominent, are there any physics engine which take advantage of low power APIs?
Actually, there is. I'm not sure what was the name. I guess AMO or Physics.js or something like this. There is. But Canon.js, the one that we are using, is running in a web worker, so that's fine too. It doesn't clock the main thread.
Okay. I hope Danilo is happy with that answer, and else he can, of course, ask you in your Zoom room to go a bit further. Next question is from Rin. Have you had the opportunity to experiment with combining this with the accelerometer API? Ooh, nice one.
No, not so much. I haven't done much with PWA. How's it called? PWA?
Doesn't
Progressive
matter.
Web.
Accelerometer API is just JavaScript API.
I haven't. Or React Native. It's not so familiar to me, but I guess it would be easy. I don't think it would be very hard to do.
Yeah, as far as I remember, it's been a while since I touched it. It's just an API that says, I don't know, device dot angle, something like that. And you just get a number back, so you could rotate the phone to move your pedal. Would be cool. So PR's welcome, right? Next question is from Drum with double M. Can you use custom textures and materials? So basically proper 3D stuff.
Yes, of course. Everything that 3JS can do is possible in React 3 Fiber. There are no limitations, no restrictions. People usually they think because it's React or because it's declarative or JSX is involved that there must be something that it can't do, but it's not the case. Every little thing that 3JS does, you can do here as well. Materials, texture, everything.
So then a follow-up question from me. Hi, from Metin. This question is from Metin. If someone has seen this demo and is like, that's it for me, I want to just experiment with this, but they don't even have experience with 3JS, would you recommend just taking time first to go raw 3JS or go in with their React experience and use React 3 Fiber?
Yeah, I would suggest that at least you go to 3js.org, check everything out, click some demos, and they have something like a small document that teaches you how to make a scene, how to place the camera, stuff like this. I guess it would be better if you do this first, but you don't need to get into 3JS in depth. You can combine both. It's a little bit like people, they ask, what should I learn first, React or, I don't know, HTML, whatever. But I think you can do both at the same time. React definitely will help you because there's no boilerplate. You can easily check things out. You have hot reload. So it will making learning actually easier. But you should definitely know the basics. What is the camera? What is the scene, lights, and so on.
You got to learn to walk before you can run.
Yeah. On the GitHub, React 3 Fiber GitHub, there's a small section called Fundamentals. It's mostly...
So that's the basic knowledge they should have before playing with React 3 Fiber. Okay, thanks.
Yep.
Next question is from Andrew Green H. Hey Paul, great talk. Could you tell us a bit about the process of learning how to write a custom React renderer?
I had no idea. There's no documentation. I was just trying it out. Trial and error. They changed the API all the time, so that was kind of a bummer. But it's possible. If you want, connect to me on Twitter and I can give you a very easy example. I have one on Code Sandbox. It's 50 lines or something. And it just gets the basics down. It's not so hard, but a little bit hard to get into, if you know what I mean.
Okay, we have time for one more question. It's from Martin Yu. Is it also possible to mouse move the lighting with 3?
Yeah, of course. I have a nice demo for this on my GitHub.
Okay, cool. So Martin Yu, I would recommend you going to Paul's GitHub. What's your GitHub handle?
Oof, I have different handles on all platforms. So
the link is on the website to your GitHub, probably.
It's DRC MDA, I think. I hope.
Okay. So for people that still have questions unanswered, or the question was answered but not deep enough, Paul still has time to answer your questions in his Zoom room, where he's going to now. Paul, I would like to thank you a lot for joining us here today and sharing this awesome project of yours.
Thank you too.
Bye-bye.